Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Each Sum Once by Doc Logic. And it's called that because we have each of the possible sums of a two-digit cage summed once in the puzzle. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. And digits and cages add up to the given sum. So, for example, if this were, say, a 4, this would have to be a 6, because these two digits must add up to 10, because the digits in this cage have to add up to the given sum, which is in the upper left-hand corner. We also have white dots, white dots link cells, which are consecutive, and not all possible dots are given. So, for example, if this were, say, a 6 here, then this would have to be 5 or 7 to make sure that these digits are consecutive because there's a white dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, let's go for the ones that we know are certain what they are. Two digits adding up to 3 is 1 and 2. Two digits adding up to 4 is 1 and 3. This can't be 1 because of the 1-2 pair in the box, so this is 3 and that's 1. 17, the two digits are 8 and 9. And then 16, two digits have to be 7 and 9. So this must be 7 here, this must be 9 here, because of the 8-9 pair in this box. Well, this 9 cannot add up to 15, so that eliminates 6 and 9, so this must be 7, 8 as a pair. These digits are consecutive. Well, we don't have any information there, so here, the 14 digits must be two 14s. Two digits adding up to 14 are either 5, 9, or 6, 8. Two digits adding up to 13 can be 4, 9, cannot be 5, 8 in this box because that would eliminate all possibilities for the 14 cage here. So it's 4, 9, or 6, 7. So in this box, we have a 6 or 9 here and a 6 or 9 here guaranteed. That means the rest of the box cannot have 6 or 9. Okay. Well, where's the 3? The 3 has to be here. No 6 or 9, so we have 1, 2, 3, 4, 5, 7, 8 as possibilities. 3 obviously cannot be here because of 3 in the box. Adding up to 5, it's either 1, 4, or 2, 3. Adding up to 6 is either 1, 5, or 2, 4. If you have 2, 4 here, though, that would eliminate all possibilities for the 5 cage. So this can't be 2, 4, it must be 1, 5 as a pair, which eliminates 1 and 4 as a possibility for the 5. To add up to 6, you have 1 through 6, but you cannot have 1, 2, 3, 5 here, so that leaves us as a possible 4 or 6, but 4 here requires a 3, 5 to be consecutive with it, so this can't be 4, because we can't have 3, 5 here because of the 2, 3 pair and the 1, 5 pair in the box. Therefore, this must be 6, which is consecutive with 7. 6 and 7 have 1 there to add up to 7. That eliminates 6 and 8 as a possibility for the 14 cage. That eliminates 4, 9 as a possibility for the 13 cage, which means the remaining digits in this left central box are 1, 2, 3, 4, and 8. Well, 8's not consecutive here. The 1, 5 pair eliminates 1 and 5 in the rest of the row, and this can't be 3 because of 3 in the column, so we have a 2, 4 pair, which can only be consecutive with 3 here. So this is 3 there. That means there's no 3 in the rest of the box. This can't be 1 because of 1 in the row. This can't be 2 because of the 2-3 pair in the row. Okay. So this is 6 or 7. We have 5 or 9 here. These digits are consecutive, but they cannot have a 6 or 7. You could have 4, 5 here, or it's 8 and 9. We don't know which. Okay. To be consecutive. These digits add up to 12, but they can't have a 3 because of the 2-3 pair in the row there and the 3 in the row there. So it's either 4 and 8 or 5 and 7, and this can't be 5 because of a 5 in the 1-5 pair in the row. Actually, let's do the remaining digits here. We have 4, 8, and 9 in the central box. We now have a 4, 8, 9 triplet in column 4, which eliminates 4, 8, and 9 in the rest of the column. So the rest of the column has to be 2, 3, 5, or 6. Well, this cannot be 2 or 3. First of all, 4 is guaranteed here, so this can't be 4. But 2 and 3 cannot be here because that would eliminate all possibilities for this cell. So this has to be 5 and 6 as a pair to be consecutive, which eliminates 5 and 6 in the rest of the column. So we have 2 and 3 there. These digits are consecutive. 4 can't be here because that's only consecutive with 3 or 5, but we have a 3, 1, 5 pair in the row. So that eliminates possibilities for 3 and 5 there. So this can't be 4, which means this can't be 8. If this is 7, this can't be 6 because that would eliminate all possibilities for cells there. So if this is 7, this has to be 8. If this is 8, it could be 7 or 9. Either one works. So we're guaranteed one of these digits is an 8. Because we have a 7 here, an 8, or it's 8 and 9 here. So this cannot be 8 here. Let's continue with digits that can add up to 10. We could be 3, 7, or 4, 6 here. We cannot have 5 and 6 here. We cannot have 1 and 2 here. If we try to have 3 and 4, the problem is the reason why we can't have 5 or 6 would be the 5-6 pair in the box. We can't have 1 or 2 because of the 1-2 pair in the box. We can't have 3 or 4 here because that would eliminate both possibilities for the 10 cage here. So this has to be 7, 8, or 8 and 9 here as the only possibilities. So we're guaranteed one of these digits has to be an 8. And this cannot be 9, because if this is 9, that would be consecutive with 2 unique digits, which 9 is not. 9 can only be consecutive with 8. And if we try to have 8, 7, 6 here, that's obviously not possible. So this can't be 8, 7, 6. It must be 9, 8, and 7 here. That means this can't be 8 or 9, which means this is a 4, 5 pair to be consecutive here, because we can't have 3 in this box, and we can't have 6, 7 in this column. So this is a 4, 5 pair, which eliminates 4 and 5 in the rest of the column. This can't be 5, it's 9. This can't be 9, it's 5. Okay. Remaining digits in this upper left-hand box are 6 through 9. No 6, 7, or 9 here because of the 9 and the 6, 7 pair in the column. So that's 8. That means 8 cannot be here or any of these. 9 eliminates 9 here. This 7 eliminates 7 there. So to add up to 11, we don't have 3, 8 available. We can't have 4, 7 available because of 3, 7, 8 in the row. So this is either 2, 9 or 5, 6 here. Either way, we have a guaranteed 6 or 9 here and a guaranteed 6 or 9 there, which eliminates 6 and 9 in the rest of the row. So that means we have 2, 4, 5 remaining. And this can't be 5 because of the 5, 6 pair in the box. Here, if we try to have 4 and 6 as a pair, that would force both of these digits to be 5, which would be a repeat in the rest of the row. So this cannot be 4, 6. It's 3, 7 as a pair. That means the remaining digit in row 2, it must be 4, 5, or 6. Okay, to add up to 8 here, we do not have 7 or 8 available, so it cannot be 1, 7. It could be 2, 6, or 3, 5. Well, we have a 2, 3 guaranteed here and a 2, 3 guaranteed here, which means the rest of the row cannot contain 2 or 3. In fact, this has to be then 1, 2, or 3 here because of the 4, 5 pair in the column and the 6, 7 pair in the column. So this can't be 2 or 3. It's guaranteed to be a 1. That leaves the rest of this as a 2, 3 pair, which is not consecutive with 6. So where is 6 in the rest of this box? It has to be here, which is only consecutive with 5. That forces this to be a 4, which is only consecutive with 3 out of 2 and 3, and therefore that's 2. 4 eliminates 4 in the rest of the column. Where is 2 in this upper left-hand box? Can't be here. It has to be one of these digits, which means this can't be 2. That's 1, which makes that a 2. 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so that's 9, which means this can't be 9. This is 6, 7 as a pair, which eliminates, and 6 eliminates 6 here, so that's 7 and 6. 7 eliminates 7 here, so it's 8 and 7. 8 eliminates 8 here, so it's 1. No 1 there. 6 eliminates 6 here, so that's 5 and 6. 5 eliminates 5 here, so it's 4 and 5. And this can't be 5 or 6 because of 5 or 6 in the row. So that's 4. That eliminates 4 here. It also eliminates 4 here, which makes this 5 and 7 as a pair, adding up to 12. 7 forces this to be 8 to be consecutive with it, and 7 eliminates 7 here, so that's 6 and 7. 5 eliminates 5 here, so this can't be 5, which means this can't be 6. We have a 9 here, so this must be a 5, 6 pair here to add up to 11. That eliminates 5 here, so it's 2, which eliminates 2 there, so it's 4. This adds up to 9. We don't have 3, 4, or 7 available. That eliminates 3, 6, 4, 5, and 2, 7, so this must be 1, 8 as a pair. And 8 eliminates 8 here, so that's 1, and that's 8. These digits are consecutive, and they cannot contain 7, 8, and 9. They cannot contain 1, 2, and 3, because one of these is guaranteed to be 2 or 3. Same with that. So it could be either 4, 5. It cannot be 5, 6, because that would eliminate all possibilities for this cage here. So no 2 here, no 6 here, because of 2 in the column. Same with this 5 and that 3. So this must be 4 with 5, because we don't have 7, 8, 9, or 1, 2, 3 available. And we can't be 5, 6 as a pair. So this is 4, which makes that 5, which makes that 6 and 2 to add up to 8. 2 eliminates 2 in the rest of the row. So that's 3, which eliminates 3 here. So that's 2 and 3 there. We have 2, 3 remaining in this upper left-hand box, and this can't be 3 because of 3 in the column. So that's 2 and 3 there. 8 eliminates 8 here, so it's 9, which makes this 4, which makes that 8. 4 eliminates 4 here, so that's 2. This can't be 2 or 8 because of 2 in the box and 8 in the row. So we have 4 and 8 there. 9 eliminates 9 here, so it's 8 and 9. 5 eliminates 5 here, so it's 1 and 5. And the rest is just basically normal Sudoku. We are left with a 9 in row 7. In row 6, we have 2, 3 remaining. This can't be 2 because of 2 in the row, so this is 3, that's 2. 1 remaining in row 1 cannot be here because of the 1s in the column, so 1 is there. We have 8 1s, we know where the last 1 is, it's there. 2, we have 8 2s, we know where the last 2 is, it's there. 3 eliminates 3 here, so it's 7 and 3. We have 8 3s, and we know where the last 3 is, it's there. Now we celebrate because we're close to solving this. 4, we don't have enough information to differentiate where the 4 is yet. 5, we have 8 5s, we know where the last 5 is, it's there. 6. In column 8, 6 can't be here or here because of 6 in the boxes, so 6 is there. We have 8 6s, and we know where the last 6 is, it's there. 7, we have 8 7s, we know where the last 7 is, it's there. 8, we have 8 8s, we know where the last 8 is, it's there. 9, the last 9 in row 5 has to be here. That gives us 8 and 9, so we know where the last 9 is there, and the rest are 4s. And that's how you solve it. Fairly straightforward. Yeah, I don't know. I'm not sure what else to say about it. Yeah, nice little puzzle. Not else, yeah, and don't really have much else to say about it. Anyways, I hope you enjoyed this episode, and I'll see you next time on Frank Puzzles. Take care.